Okay, so I want to find the missing lengths r and y in the given triangle. And so I know that I have an angle here in degrees. And so I know that sine of theta, or cosine of theta, is equal to, if I want to call this x, adjacent, so adjacent over hypotenuse, so x over r. So cosine of theta will be equal to, cosine of 26 degrees, actually. So this is my, so let's just write these out in words. So this is my adjacent, so opposite of this angle is the y, and this is the hypotenuse, and this is my adjacent side. So cosine of 26 degrees will be equal to adjacent over hypotenuse, so 3.6 over r. So I can multiply the r on both sides. I'll have r cosine 26 is equal to 3.6, so r is equal to 3.6 divided by cosine 26. And when I type this into my calculator, I want to make sure that I'm in degree mode. So let's type that in. And so I get 3.235, round to one decimal place, so 3.2. And then for the, I also know that tangent of 26 degrees is equal to y over, the opposite, over 3.6. And so I can multiply the 3.6 over, and I get 3.6 tangent 26 is equal to y. And if I plug that into my calculator, and I'm already in degree mode, so I should get 1.75, so I'll round that to 1.8. A line passing through the origin and a point P equals A10. So we'll have A10. So there's my point. Makes an angle of 26 degrees with the x-axis. Find the missing coordinate of P. And so since that point is at AP, I could make a triangle here, and this side of the triangle is 10, and this side of the triangle is A. And so I can use my trig value. I can say tangent of 26 degrees. And it's just kind of a coincidence that we ended up with 26 on both of these problems, but anyhow, is equal to 10 over A. So I can multiply A over and divide by tangent 26. And so if I do 10 divided by tangent of 26 degrees, that gives me 20.5, round to one decimal, yeah. So 20.5, and I don't really have units here because I'm just talking about the x-coordinate on the axis. Okay, Josie walked 100 feet away from a light post. Then she measured the angle of elevation from her ground at her feet to the light to be 20 degrees. How tall is the light post? So 100 feet away, and here's Josie standing here. And she measured the angle of elevation from her feet to the top of the light post to be 20 degrees. So the question is, how tall is the light post? So I'll just call that h for the height. So I know that tangent of 20 degrees is equal to h over 100. And so I can use my trig function to do that. So I can multiply by 100. I get h is equal to 100 tangent of 20. And if I plug that into my calculator, again, make sure I'm in degree mode. You should just check every time. Make sure. I get 36.4 if I round. And what are the units? Here I have a situation where I might have units. The 100 was measured in feet, so everything's in feet here. So this is feet. So well, I don't know where that e came from. So feet. So 36.4 feet tall is the height of the lamppost. The angle of elevation from building A to the top of building B is 43 degrees. And the angle of elevation from building B to the top of building A is 22 degrees. How tall is building B? So what I can do is I can use this triangle here to give me information about this distance here. So I know that the height of the building A is 150 feet, so I know that tangent of 22 degrees is going to be equal to 150 over x. So x tangent 22 equals 150. So x is equal to 150 over tangent 22. And so that gives me that x is equal to, again, in degree mode, 371.26 feet. And from that, I can find the height of building B. So if I call that H, and I can look at this triangle now. And so I know from that triangle that tangent of 43 degrees is equal to the opposite, which is H, over the adjacent side, which is 371.26 that I just found. And so that gives me H is equal to 371.26, tangent of 43 degrees. Whoops, not 34, 43. And if I type that in, I get 346.2 for the height of the building. And the units of that are feet, because everything's in feet. Okay?
All right, so for number 5, it says convert 5 radians to degrees. So we have 5 radians. And the way we convert to radians is we have 1 over pi radians times 180 degrees. And so that means the units of radians will cancel out. And we get, right. So when we put that into our calculator, we get 5 divided by pi times 180. And that's equal to 286.48 degrees. Right, so find the value of the radius and the measure of the angle in both degrees and radians. Right, so we have a point here, point P. Its x value is this and its y value is that. And so that means that this this leg here is going to have a value of negative 2.63, and the y value is also going to be negative 1.83. So that means we have a triangle with 2 legs. We can use Pythagorean theorem to find the hypotenuse. So r squared is equal to 2.6 squared plus 1.3 squared. So both are going to be negative. And so that's going to equal that squared plus 1.8 squared. R squared is equal to 10.27. And then we're going to square root both sides. So R is going to be equal to 3.2. So that's R, 3.2. And now we need to find the degrees and radians. So
we know that S is equal to R times theta, where theta is in radians. And so from that formula, we can say that the theta is going to be equal to S divided by R. And so we can compute that. So the S is 12 centimeters, and I'm going to divide that by my radius, which is 3.2. And so when we do that division, we get 3.75. So it's 3.75 radians. And so next, we want that in degrees. And so we know that if we have a theta in radians, I can multiply that by 180 over pi, and I can get that theta in degrees. And so we can take that 3.75 and multiply that by 180 divided by pi, and that gives us 214.85 degrees. Oh, round to 1 decimal. So 214.9 degrees. Next, find the exact coordinates of a point at an angle of 7 pi over 6 on a circle of radius 2 centered at the origin. So I know that the coordinates of that point, x is going to be equal to r cosine theta, and y is going to be equal to r sine of theta. And so when I plug this into my calculator, I can put in 2 cosine of 7 pi over 6 and 2 sine of 7 pi over 6. And when I plug this in, I need to make sure I'm in radian mode because my angle is measured in radians. And so for the x coordinate, I get negative 1.73. And for the y coordinate, I get negative 1. Okay, I'm just looking back because I was trying to figure out what to round to, but I just noticed that it says find the exact coordinates. And so if we're doing exact coordinates, that means we need to, this 1.73 that I rounded, that's not an exact coordinate. So if we remember 7 pi over 6, what is the cosine value of 7 pi over 6? So I'm dividing my pi into 6 equal pieces. So this is 6 pi over 6, so 7 pi over 6 is here. And so the x coordinate is root 3 over 2, and the y coordinate, or negative root 3 over 2, and this is negative 1/2. And so this is on my unit circle. And so the cosine value of 7 pi over 6 is actually root 3 over 2. So let me write that down. So it's 2, so it's going to be, so it'll be 2 times negative root 3 over 2. So it should be negative root 3. And then negative 1, since that's a terminating decimal, that is an exact value. So those are our functions in terms of an exact value. Okay, P is a point on the circle of radius 5 centimeters. The length of the arc is 14 centimeters. What are the coordinates of point P? Okay, so to find that, first we want to find the angle theta. So if we remember S equals R theta, where theta is in radians. So I'll just write that theta with a subscript radians. So we know that theta in radians is equal to S over R, which is equal to 14 over 5. So that's 2.8. And this is in radians. And so then I can find the coordinates of my point by, I can say x is equal to r cosine theta, and y is equal to r sine theta. So we can go ahead and plug that in. It says around to 2 decimal places here, so I know that I'm going to be finding a decimal approximation and rounding. So the radius again is 5 cosine, and my theta is 2.8. And again, this is in radians, so I want to make sure that I'm in radian mode when I type this in. Okay, so I plugged that into my calculator, checking that I'm in radian mode. 5 cosine of 2.8 is negative 4.71 if I round to 2 decimal places. And for 5 sine of 2.8, I get 1.67. Next, a weather satellite orbits the Earth 500 miles above the Earth's surface. What is the radian measure of the angle through which the satellite moves in traveling 600 miles along its orbit? Okay, and so what we have here is the satellites traveling around the surface of the Earth. And so we know that the Earth's radius is 3,960 miles, and then we have an additional 500. So from the center of the Earth all the way out to that point is going to be, so my radius is going to be equal to 3,960 plus 500. So 4,460. Okay, and then it's asking what is the angle measured when the satellite moves 600 miles along its orbit. So when this arc length is 600 miles, it's asking for this angle theta that's made. So if we can compute that, S equals r theta. So it asks the radian measure of the angle. So this theta is in radians, so we can just do theta equals S over R. So we can go ahead and compute that. So S is 600, and our radius is 4,460. So it's 0.134 radians.